And thank you to our audience for joining. We really appreciate all of you taking the time to follow our technology journey today and especially over the last year. Honestly, I wish we could be together in person, but I am grateful we're still able to connect through the power of technology. Over the last 18 months, connection has been one of the world's most important priorities, whether it's connecting to our families, to our classmates, or to our colleagues. We all want the means to stay close to one another. Intel's goal is to create world-changing technology to improve the life of every person on Earth. And that goal is more critical now than ever, given how essential the PC has become. It's the device people rely on to stay connected, to unlock their potential, and to focus on what matters most. One thing I am really grateful for is that the challenges of the pandemic have actually given us the opportunity to bring people together through technology even more. With our industry partners, we've distributed PCs and bolstered connectivity in communities around the world, including over 1 million students globally. We've also worked with healthcare partners to provide high-performance compute resources for COVID-19 and other healthcare research. Intel Core processors are at the heart of tens of millions of PCs around the world. We're committed to powering the premium, no-compromise experiences people deserve. Now today, we're going to share more details of our next major step in this compute journey, our 12th Gen Intel Core processor family, codenamed Alder Lake. I'm thrilled to introduce you to the new unlocked 12th Gen Intel Core desktop processors. And let me start by showing you the retail box here we're kind of excited about. Now we've got a lot to share today, so I do want to jump right to the points, the big headlines for 12th Gen. So you're the first to hear today that with this launch, the unlocked Core i9-12900K is the world's best gaming processor. It brings the best gaming performance compared to ourselves and our competition. With up to 8 performance cores, or P-cores for short, for gaming, and with frequencies up to a max turbo boost of 5.2 gigahertz and 19% gen-over-gen performance improvement, and also up to 8 efficient cores, or E-cores for short, which allow for offloading tasks or things like streaming and recording so your game experience isn't compromised. In addition, 12th Gen also delivers the best overclocking experience. It was designed from the ground up to comprehend the needs of overclockers who always want to take our best processor and push it to its limits. We provide industry-leading overclocking tools for the ultimate performance customization. With 12th Gen, we include the ability to overclock the efficient cores and both DDR4 and DDR5 memory, as well as updates to the Intel Extreme Tuning utility to allow you more control than ever. And then finally, 12th Gen brings a giant leap for content creation. We've taken a huge step forward in our multi-thread performance and responsiveness, which is so critical for creators, so that they can stay focused on their creative flow. This is bringing a 30% performance improvement versus 11th Gen. And with up to 16 total cores and 24 threads, creators get both high frequencies and responsiveness for tasks like 3D design and the scalable multi-threading to not only offload background tasks, but also take on parallel tasks like image and video rendering. But it isn't only about core performance. We're also leading the industry with the transition to both DDR5 and PCIe 5.0 to enhance gaming and creator experiences. So now that you've heard about what 12th Gen delivers, let's take a step back to talk about what makes all of that possible. So many of you were at Architecture Day and heard from our engineering teams who unpacked the latest architectural advancements we're making as a company. The 12th Gen Core family is the first one built on Intel 7 process technology. And the architecture scales from the highest performance enthusiast desktops to the thinnest, most responsive laptops, which is super exciting. It's the first time in generations that we've supported all client segments on the same architecture. It's truly a family platform. Now, it's not an incremental architecture improvement. It's a new design from the ground up. This is the first performance hybrid design. introducing two all-new core microarchitectures, the performance cores and the efficient cores, and as well, the new Intel Thread Director technology, which actually helps the OS to assign the right workload on the right core at the right time. Now, you're going to hear lots more about that later in today's presentation. But I want to talk a little bit more about the cores. It wasn't enough to deliver our first performance hybrid design. The cores themselves needed to be something special. The P cores provide a geo-mean improvement of about 19% across a wide range of workloads over our current 11th gen Intel Core architecture at the same frequency. And then the E cores bring a massive increase in multi-threaded performance, all with a more efficient use of power and area. And then the Intel Thread Director actually enables the intelligent optimization of the placement of the workloads onto individual cores. Now, if we had delivered a product with just one or the other of these new cores on their own, it would have been a generational step forward. Putting them together and optimizing the use of them is groundbreaking. Now, as I was just saying, one of our most important goals when designing 12th Gen was to support all client segments through a single, highly scalable SoC architecture in order to ensure broad ecosystem adoption. Now, what we're going to focus on today is the desktop part, the two-chip socketed desktop platform with leadership performance, power efficiency, memory, and I/O. And then looking forward, we'll bring our performance hybrid architecture to the high-performance mobile BGA package, which adds imaging, integrates XE graphics, Thunderbolt 4, and Wi-Fi 6E. And then finally, for ultra-mobile, we'll bring a thin, low-power, high-density package with optimized I/O and power delivery. What's really exciting today is that the 12th Gen family of processors isn't just a vision anymore. We're already shipping 12th Gen desktop processors and chipsets to our customers around the world. This new architecture is really exciting for us, and it's the foundation of our products for generations to come. I'm very proud that desktop will be the first to market, and I'm excited for you to hear more about the 12th Gen desktop in today's session. Our partnership with the ecosystem is unmatched. When you buy products from Intel, you're buying from a company with resources that stretch across the entire PC ecosystem. Now, this enables us to work with industry partners in unique ways in order to ensure that we're optimizing every part of the platform. It includes everything from the operating system, the components, the OEMs, retail and channel partners, and so forth. And that extensive work that we and our partners do in innovation and enabling and testing enables us to bring new advances in technology like DDR5 to life. And it also ensures that people's experiences are optimal on their new systems. And as you can tell, our partners are as excited as we are about the new 12th Gen desktop processors. We're expecting to see over 140 customers in more than 30 countries add 12th Gen enthusiast desktops to their lineups by the end of the year. And we also expect to see more than 60 motherboards ready to support the ecosystem and these enthusiast designs. And then as we look forward into 2022, we expect over 100 additional new desktop designs, including mainstream SKUs, all-in-ones, and small form factors. You'll hear more about these early next year. Now, to deep dive into the 12th Gen desktop platforms, I'm going to turn it over to Marcus Kennedy, our General Manager of Gaming, Creator, and Esports.
Thanks, Mandy. It's great to be here, and thanks to all of you for joining us. Let's go ahead and dig into more of what makes 12th generation unique. So, as you heard Mandy say, we are able to claim that this is the world's best gaming processor. Now, this is an extremely proud moment for me because not only do I hear about how important this is as a halo from our customers, but as a former professional gamer, I know how overall system performance impacts your performance and experience as a player, which includes whether you're talking about frequency, base or overclocking, smoothness, and latency. So as you build your computer like I have, we hope that you'll use the 12th generation processors and you're as excited about it as we are. With the improvement in multi-threaded performance, this is our best PC product for content creation, and we'll show you some data on that. And last, you will hear later on today of how we've involved and enhanced the overclocking experience for the entire platform. So let's take a deeper look into the 12th generation platform. Now, you heard Mandy talk a little bit about the P-cores and the E-cores, and I just wanted to say that our new P-core microarchitecture is the highest performing CPU core that we've ever built. We're talking 19% performance improvement gen over gen, and that's just awesome. It's designed for speed and pushes the limits of low latency and single-threaded application performance. These P-cores are optimized for the single and lightly threaded performance, which enhances both gaming and productivity workloads. Now, our new E-core microarchitecture is designed for throughput efficiency, which enables scalable, multi-threaded performance for modern multitasking. They're also optimized for scaling highly threaded workloads, which minimizes interruptions from background task management. The main intent of our new performance hybrid architecture really is all about adaptability for those real-world usages, and these cores help enable that. They help the system adapt to running workloads with either more performance or higher efficiency, depending on what kinds of applications they're running. For example, when you compare with the Skylake core, which is our most prolific CPU microarchitecture in single-thread performance, the efficient core achieves 40% more performance at the same power, or delivers the same performance while consuming less than 40% of the power. Now, if we talk about throughput performance, 4 of those E-cores offer 80% more performance while still consuming less power than 2 Skylake cores running 4 threads, or the same throughput performance while consuming 80% less power. So as you can see with those numbers, while these E-cores are also highly performant cores, they're also capable of adapting to your needs as a user. Our new performance hybrid architecture is going to be available on all of the unlocked 12th generation core desktop processors that we're announcing today. Now, about those performance improvements on the P-core. We showed you this picture at Architecture Day, which details the average performance improvement you heard Mandy talk about from our 11th generation core architecture cores to the new P-cores at the same frequency. As you can see, the effect of the microarchitectural enhancements on general purpose performance provides an average improvement of 19% across a wide range of existing workloads, which demonstrates why we are calling this our highest performant client core ever. This is really just to give you a taste for what the performance of the architecture looks like for generic workloads, and you'll hear Guy talk a little bit more in detail about this later. Now I want to talk a little bit more about this Intel Thread Director because it really is one of the most significant and exciting innovations in the new performance hybrid architecture. It's built on top of our performance monitoring unit that provides the best hardware telemetry in the industry. Since we have 2 different core types, the placement of threads on those cores is really key, and additional characterizations of those workloads will drive that. With this new Intel Thread Director, we're now able to provide to the OS scheduler additional workload characterization information that it didn't have before at the time of making those scheduling decisions. The most exciting part of Intel Thread Director is that it monitors instruction mix, state of core, as well as other relevant microarchitecture telemetry at a very granular level. And then it takes that information and helps the OS make those more intelligent scheduling decisions. Now, traditionally, the OS would have made those decisions based on limited stats that are available, which are aligned to foreground, background workload, or task characterization. But with the new Intel Thread Director, it adds a new dimension with this hardware telemetry so that those threads with higher performance requirements end up on those P-cores. You're going to get to see a demo of this fantastic innovation working later on in today's presentation. Now, we've also made some changes to our cache architecture. With the 12th generation Intel Core architecture, we're introducing a new common Intel Smart Cache architecture, which is shared among the P-cores, E-cores, and the processor graphics. Additionally, we increased both our shared Intel Smart Cache at L3 and our L2 cache sizes, which drives large memory capacity and reduced latency. And we did this because we know how important these are in order to deliver fast game loading and smooth frame rates for our enthusiast community. And of course, as a result, we've seen increased performance on gaming titles like League of Legends, Hitman 3, and many more. Now, beyond those architectural advancements, there are a ton of other new features and improvements that we've made to lead the way in bringing innovative and high-performance computing to the market with these 12th generation desktop processors. A lot of those that you can see on this slide. from the increased L2 and L3 shared cache I just talked about to PCIe Gen 4.0 support, which comes via both the processor and the new chipset that we're going to talk about later, as well as enhanced versions of overclocking for both memory, which we launched with Rocket Lake and carried forward, and core, as well as our integrated UHD graphics, which has Xe architecture. So when you put all of these together, you can see that the 12th generation family of processors is set to bring in a new generation of leadership. Now, when you combine this platform that's going to reach up to 5.2 gigahertz on the i9K SKU with our other fantastic technologies like killer Wi-Fi 6E and Intel Thunderbolt 4, it brings you not just a fantastic gaming experience, but also one built to create. Now, with this 12th generation core, we do continue our legacy of leadership and innovation in the industry. We're leading the transition to PCIe 5.0, which is ready to usher in a wave of new devices taking advantage of those 16 PCIe 5.0 lanes that come directly from the CPU. And they're going to deliver up to twice the I/O throughput for your discrete graphics and your storage upgrades. We're also leading the industry transition to DDR5. And this is going to deliver faster speeds and higher bandwidths for enhanced workload performance and productivity. Now, the DDR5 will get up to 4,800 megatransfers per second, and DDR4 will be up to 3,200. And as we always do, we really expect the enthusiast community to take full advantage of the greater experiences enabled as our partners in the ecosystem launch and continue to mature these new technologies in the market. Now, as you all know, the CPU is only one part of the overall platform. So alongside these 12th generation core desktop processors, we're also introducing the Intel 600 series chipset. Now what that's going to deliver is new PCIe Gen 4.0 lanes from the chipset, which alongside those PCIe Gen 3.0 gives you an increased total of up to 28 PCIe lanes off the chipset alone. We've added additional integrated USB 3.2 Gen 2x2 20 gigs, which will provide you up to twice the USB bandwidth versus the 10 gig 2x1 that enables fast data transfers. We've increased the DMI generation from 3.0 to 4.0. And that's going to increase the throughput speed between the CPU and the chipset, which will help you take advantage of all of these things that we have to offer. Now lastly, and as an old data center guy, this is really exciting for me, we have extended the Intel Volume Management device from our data center now to the client for the first time. Now, if you're unfamiliar with it, VMD offers an easy way to manage your storage devices that allows direct control and management of those NVMe SSDs we all love from the PCIe bus without the need for additional RAID or other hardware adapters. So when you pair these chipsets with the 12th generation processors, it really makes this release our most reliable and advanced platform. Now we made these claims on this slide earlier, and you all know that we don't like to make claims without having the data. So we're going to show you some right now. To go a little deeper into our performance leadership, we're showing here a comparison of more than 30 titles against our last generation desktop processor first. In choosing our titles, we made sure to pick titles from different segments of the industry so we can get a really comprehensive look at how gaming really works on this new architecture. We measure these either by an in-game benchmark mode performance if they have them where available, or frames per second alone where the benchmark mode is unavailable. So with this new 12th generation performance hybrid architecture, you can see, as we're showing on this slide, that we're delivering a substantial leap in generational performance. This range of results on this slide show you a geo-mean of 13% gain generation over generation. And now we can't obviously claim world's best gaming processor without talking about competition. And so we believe that we can make this claim because our 12th generation Intel Core i9 12900K scored better than our competitors on the majority of those 31 game titles that we tested. Now, we're going to show you a range of results represented over a full data set. And so as you can see here, we show a range from just under par to all the way up to 30% over competition across those 31 games. We test these titles, like I mentioned earlier, on these benchmark modes or repeatable workloads. And all of this testing is on Windows 11 with the latest NVIDIA 3090 graphics card and DDR5 memory. And before you ask, we did see the same headlines you all saw about our competitors' claims of performance on Windows 11, and we realized there's going to be a Windows 11 software update coming soon. Once that software update's released, we're going to remeasure all the games, including those 4 eSport titles in our gaming test suite, and we're going to validate our gaming performance leadership based on that new run. Once we have that data, we promise we'll share all of our findings with you. But that said, we are confident that even with the upcoming patch, we stand behind our claim. Because as you can see, our new 12th generation hybrid architecture delivers real performance gains both against our previous generation and against comp. More is going to be covered in detail in our What to Expect guide that you'll get, but we ran these tests at 1080p, which, as you all know, is a very common resolution. And especially with those high refresh rate monitors, we wanted to really zero in on the CPU benefit. I'm going to be going a little into more depth on how we enabled some of these gains by working with the ISV shortly. So as you can see, the 12th generation core processors, including our performance hybrid architecture, we're delivering the best gaming processor with performance leadership, which goes all the way up to 30% faster. I'm also sure that you're all curious about DDR5 versus DDR4 as well. While DDR5 offers the absolute best in gaming performance and will get better over time, we also tested across all of these titles with DDR4 as well, and we all know that it's very mature. It does still offer great performance, and I am happy to share that even with DDR4, the 12900K would still be the world's best gaming processor. So to summarize, while DDR5 offers the absolute best in gaming performance and will get better with time, DDR4 is still very mature and still offers great performance when paired with the 12th generation processors. Now, if we look beyond gaming, there's great news for content creators in this launch as well. We're delivering improved multi-threaded performance for content creators. Due to its combination of 8 performance cores and 8 efficient cores, creators are going to see massive improvements in performance in the highly threaded content creation workloads. Higher core count, improved IPC, and larger cache sizes available with these 12th generation processors deliver that higher performance versus the previous generation systems. Additionally, new multi-frame rendering features in Adobe After Effects are going to be able to leverage multiple CPU cores in parallel, which gives you improved export and preview rendering performance. While we're going to have a whole section later on today on measuring content creation performance, I wanted to share the highlight of how across the content creation usage models, whether it's photo editing, video editing, modeling, or rendering, there will be significant gains in performance. 12th generation is our best content creation product ever, with tremendous gen over gen improvements and closes the gap with competition. This hybrid improves performance on content creation workflows, and that can take advantage of these E-cores by offloading parts of the workflow to those E-cores. In our testing of these content creation workflows that you're actually going to see Ivan show you a demo of later, we've actually seen 12th generation be 30% faster than the competition. So really excited to show you that demo a little later on. Now, content is king, and we understand the need to partner across the ecosystem. So we continue to work with game developers and content creators, supporting them with tools, optimizations, and partnerships. We work closely with thousands of game developers, game engines, middleware, and application developers across the industry. So what you see here on this slide is a selection of game titles, content creation tools, and software with whom we engage to allow us to deliver those top performance benefits on Intel CPUs, which take us beyond just memory scaling or simple frequency scaling. Take Hitman 3, for example, where enabling has been done for hybrid-aware scheduling in the game engine. Features such as the object destruction physics as well as animations benefit from the increased core count in those 12th generation core processors. Mountain Blade 2 is one example of a highly threaded game, and as you can see, it responds very well to running simultaneously on all of the cores offered in our new platform, not on just the P cores. Also, changes to the threading system mean that those time-critical tasks related to rendering favor the P cores with their better single-threaded performance, and that gives more opportunity for the physics to run in parallel on those efficiency cores. Really, at its simplest level, the game recognizes that not all tasks are time-critical and allows the OS more flexibility on where to schedule the work. And that's where that thread director that we discussed earlier comes in, because it then is able to do so in the most effective and efficient way possible. Now, along with gamers, creators are an important part of the desktop enthusiast ecosystem. There's more than 300 million of them worldwide, and it makes up a large part of our PC industry. We've had long-standing partnerships with the industry's leading software vendors, a sample of which you can see featured on this slide. Now, these strong collaborations with the ecosystem have enabled us to consistently deliver deeply optimized and performant experiences for the content creation community. An example of how we enabled better content creation is the work that we did with the Open Image Denoiser, or OIDN for those of you who like acronyms, to remove thread affinities prior to integrating it into Arnold. And that helps improve performance and allows Thread Director to appropriately schedule threads for the best user experience. Another example is Magic Vegas Pro, where we helped to optimize the application in the past to take advantage of Intel Deep Learning Boost. That deep collaboration continues as we worked with Magix to integrate the latest version of hybrid-aware OpenVINO to continue taking advantage of the AI capabilities. Now, we will continue to partner with the ecosystem to ensure that gamers and creators get the best experience possible on our platforms, and developers get to see their best vision realized most effectively on the PC. Now, since I've been talking about software, I want to bring out Intel fellow Guy Theron to share more about what that looks like. Guy?
Thanks, Marcus. It's great to be here today to talk to you about our 12th Gen products. I was one of the co-inventors of hybrid architecture and Intel Thread Director, and I've been driving changes to our power-related nomenclature. So now I'll tell you about software enabling, a little on 12th Gen core performance and why we chose to implement hybrid, and then I'll inform on changes to our power definitions. To deliver consistent optimal performance, hybrid computing requires the hardware and the software to work together seamlessly to manage the differences in performance between the P cores and the E cores, putting the right work in the right place at the right time to deliver the best experience. We enjoy a highly productive collaborative relationship with Microsoft for both platform development and assessment of successive operating system releases, including extensive testing with our joint teams to ensure that our end user value of our products endures over time. Our relationship goes back decades. We had an outstanding partnership to optimize Windows 11 for hybrid. This includes general placement of work, for example, placing demanding work successively on P cores, then E cores, then the SMT sibling of P cores, which is a change from Windows 10 scheduling policy, and includes support for the efficient placement of work identified as background, or we might say wasted work, on E cores. Additionally, the OS utilizes information from the 12th Gen Intel Thread Director technology to understand the nature of workloads, allowing the OS to prioritize workloads for execution on core types, providing them the most benefit. Intel Thread Director also helps the OS keep low scalability threads from consuming precious power resources by placing them on E cores. Now, let's take a look at a 12th Gen system running Windows 11. I want to show you an application we developed that reports the location of workload threads we create among the cores on the processor. On the left-hand side, we have our performance cores. They contain 2 logical processors per core. On the right-hand side, we have our efficient cores. On the far right-hand side, we have a number of workload threads that are demanding that we can create. We can create different kinds of threads, including a default high-demand thread, threads that contain vector floating point instructions, threads that contain AVX2-based VNNI instructions, and also background threads, threads that have elected through the OS APIs to say that they have a low quality of service requirement. Now, I'll mention that we're going to display the threads that we run on this chart. And on the left-hand side, you'll see up to 2 threads on the P cores, and due to visual artifacts, you may see more. But generally speaking, the black rim threads are one of the SMT siblings, and the gray rim threads are one of the other SMT sibling. So now, let's create some threads. We'll start running some default threads, and as you can see, they populate onto the P cores. Now remember, we're not placing the work there. Intel Thread Director is just giving information to the OS. The OS sees that the P cores are more performant, and for these demanding workloads, it places them on the P cores. Now I'm going to start some vector floating point threads. Vector floating point threads get more performance from the P cores than the default. And so the OS will start placing those on the P cores, pushing off the default threads onto the E cores. Now I'll start some AVX2 VNNI threads. And you can see the OS sees that they are more beneficial to be placed on the P cores. And so as they come on, we'll push the green threads, the default threads, off onto the E cores. And lastly, let's create some background threads. these are threads that elect that they have low quality of service. So the OS sees those threads and places those on the E cores as part of OS policy for background threads. So the big takeaway here is that Intel Thread Director allows the OS to consistently maximize the performance of your device and deliver the best experience by minimizing performance variability. Otherwise, the threads could just land on one core type or another. Thread Director helps the OS know the best place to put the work. And that's why we say putting the right work in the right place at the right time. I'm sure you're wondering about 12th Gen platform experience on Windows 10 and Linux Chrome. Windows 10 implements an earlier version of Intel Thread Director. It consumes core performance and efficiency information, but does not utilize software thread-specific feedback like Windows 11. This can result in some additional benchmark run-to-run performance variability, but the end-user experience of 12th Gen on Windows 10 is awesome. Similarly, Linux and Chrome Intel Thread Director support is currently work in progress. But the existing ITMT Linux scheduler comprehends the diversity and performance between the core types, leveraging the Intel Speed Shift technology interface. And as such, the 12th Gen end user experience is also really great on Linux. For applications, there are a few simple things that developers can do to make sure that the OS and the new 12th Gen processor with Intel Thread Director deliver maximum value. We are publishing application development white papers shortly after the Intel On event. You can find them on developer.intel.com. These white papers help ISVs optimize for hybrid platforms and include some specific guidance to, number one, adopt the use of quality service APIs set appropriately for the application, similar to what you just saw with the background work that I showed in the demo. Number two, use standard OS interfaces for logical processor enumeration rather than hand enumeration via CPU ID. You'll get the right answer by doing it that way. Number three, utilize updated versions of programming libraries that include support for new instructions to realize their performance benefits. And lastly, don't set hard affinity, as it can inhibit optimal software thread placement and interfere with the placement that you saw in the demo. So, our white papers describe some easy modern programming practices that will help ensure applications deliver the best possible experience on 12th Gen products with hybrid architecture. As far as testing goes, we performed extensive testing in search of any potential software incompatibilities with hybrid. The main issues uncovered include hard affinity and attempts at direct enumeration of cores and threads using CPU ID. We also found a specific problem with software assumptions of uniformity with ISO register and flag values outside of our specifications. Specifically, we found a problem with gaming copy protection where the hybrid cores were detected as a different system and thus it failed. The DRM vendor, Denuvo, has resolved the issue and is providing updates to the impacted games. Historically, 91 games of Denuvo DRM were impacted. And to date, there are 32 yet to be remedied because we've been working with them. There are 18 in our top 200 list. 16 of these are updated and on track for fixing by launch, with the remaining 2 expected to be fixed by the end of the month. In addition, we have provided OEMs with the remedies for the ability to run any other game that is protected by the Denuvo DRM. So if you bought an old game and you love your old game and you put it on a 12th Gen platform and it's covered by Denuvo, you'll be able to play it. No worries. Rest assured. Now let's talk a little bit about performance. Specifically, the 12th Gen core performance. When we look at this spec-in example of single-threaded fixed frequency performance on 12th Gen P core and E cores, a few things stand out. The first is a significant improvement between our 11th Gen desktop product and the 12th Gen P core. Perhaps an even more interesting thing to point out is that the 12th Gen E core performance is actually greater than our 10th Gen processor. Let that sink in. And so it's a bigger, great performant processor. Performance hybrid is really the combination of two very performant core types. Now let me talk to you about the question we get asked often, why? Why did you do performance hybrid? Well, over time, we've seen application software evolve to deliver significant end-user benefit and client from increased core count. Rather than take a simple copy approach to increase core count, we took the route of combining heterogeneous core types for our performance hybrid architecture. The hybrid architecture combines both the P cores and E cores to deliver higher multi-thread performance for the same power versus the other technique. So 4 E cores fits in about the same area as a single P core, but deliver about 1.6x the multi-thread throughput. So hybrid is a much more efficient approach. The i9-12900K offers a big improvement in pure multi-thread throughput performance compared to our 11th gen products. It's nearly 50% faster than the i9-11900K in an unconstrained power environment. That is 250 watts for 11th gen and 241 watts for 12th gen. This is a great advancement in performance per watt. Of course, we know that desktop users buying the K SKUs want maximum performance and aren't as concerned about power efficiency as they are about getting every last frame. But it's really interesting to see what happens when you start to scale down the sustained power. We ran these same tests on platforms limiting power to 125 and 65 watts. And you can see that the combination of the Intel 7 process technology and the performance hybrid implementation results in 12th gen Intel Core processor running at just 65 watts, producing the same multi-threaded performance as 11th gen running at 250 watts. This is a huge performance efficiency gain, gen over gen, and more clearly demonstrates, I hope, why the future is hybrid. Now, I'll tell you about changes to our power definitions and default settings. Back when the processor was the single high power component in the platform, it made a lot of sense to describe its power dissipation as the thermal design power, or TDP. With the advent of additional high power platform components, for example the graphics, as well as the introduction of turbo and its often limited but much higher burst power, the term thermal design power as we define it is no longer an accurate descriptor of either the platform design point or of the dissipation of the parts. While the technical definition does not change, the new term we will be using moving forward is processor-based power instead of TDP. We will also be conveying the maximum turbo power of our parts and technical specifications. This is the default power limit 2 value. In addition, for the K SKUs, we have changed the silicon default values of our power controls to allow sustained operation at maximum turbo power, as opposed to the limited duration found in previous products. The silicon default for the K SKU will look like the graph on the right, where PL1 equal PL2 equal 241 watts sustained. This change reflects the typical practice of many of our channel partners today. Again, platform technical specifications remain the same. That is, platform vendors will configure their systems in accordance with the platform's power delivery and thermal dissipation capabilities. We recommend that the 12th gen K SKU platforms be evaluated in their default configuration to best assess maximum performance capability. Now I'll pass it over to Ivan to talk about how to measure 12th generation performance.
Thanks, Guy. I'm Ivan Goldwasser, Senior Director for Performance Marketing. I'm going to showcase some of the tremendous innovations we've seen here on 12th gen, and I just can't wait for this to get into the hands of you and your customers. I'm going to talk about 3 different things today. First, I'll touch on gaming performance. Then we'll talk about how we think about measuring performance hybrid and also showcase some demos. And last, we'll talk about some new benchmarks. So let's go ahead and get started with gaming. We've done extensive game testing, and Marcus shared some of these results earlier. All the work that the team has done between engineering and software has led to phenomenal 25% gen-on-gen gains across these titles and across a selection of racing, strategy, first-person shooters, and others compared to our 11th gen. I want us to also talk about a few notes on how we did our testing. Windows 11 and Defender, we ran everything with Windows 11 with Defender on and VBS on, as well as on the latest NVIDIA RTX 3090 graphics card. We configured 11th Gen to be the best that it could be with adaptive boost technology and 64 gigabytes of the industry best CL14 DDR4 latencies. We ran everything at 1080p, which is still one of the most common resolutions, especially with high refresh rate monitors. 12th Gen is just going to be amazing for gamers. With all the innovations in 12th Gen and performance hybrid architecture, we spent a lot of time thinking through how people multitask and how to quantify those benefits. When multitasking, you currently break things down into two high-level categories. First, you have user-initiated activities, which could range from quick interactive interactions to long-duration activities to experiential or gaming. And then you also have system-initiated processes that you have less direct control over. We broke this down into three different categories based on background activity. The first is user-initiated short-duration activities. So this could be you're transcoding a video, doing some edits to photos. I'm going to show a demo here in a bit. We'll be transcoding a video while editing photos. Both the activities are important and designated by the user, so we use a geomean of both the foreground and background activities. Next, we have user-initiated long-duration activities. So this could be you're transcoding your entire library or you're streaming a video. And in this case, the background task may not be as time-critical, but it's important to qualify the progress during your session, as well as to ensure that the quality is up to expectations. We're showing another demo here doing gaming while streaming plus record. In this case, we focus on the foreground activity with the gameplay, but the background shouldn't drop frames and must deliver the appropriate quality. And the last is we have system-initiated tasks. So this could be your IT environment or a virus scan. For example, you might be creating a presentation or emailing on an IT-configured system. In this case, you would also focus on the foreground metric, but you want to qualify the system overhead to ensure a comparison of the same amount of work. We're not going to be doing any demos of this today, but stay tuned for more to come on future disclosures. The two demos we have today that'll showcase the value of 12th Gen performance hybrid architecture. The first is we'll showcase gaming while streaming and recording. And second, we'll do a content creation demo using Adobe Premiere and Lightroom Classic. I'm actually going to kick this one off right now, and then we'll come back to it because it takes a little while to run through. For the game stream and record, my colleague Chris will be comparing a 12th Gen Core i9 12900K and 11th Gen Core i9 11900K. These are both similarly configured platforms, both using an NVIDIA RTX 3090 GPU. He's going to be using Mountain Blade 2 Bannerlord running its included benchmark mode. As Marcus mentioned earlier, this game scales very well with core count, and the 12th Gen with Performance Hybrid delivers 19% higher frame rates compared to 11th Gen for a much more immersive gaming experience. Gaming is a communal activity, and more people are streaming and recording their gameplay. OBS is one of the most popular streaming programs, and we use it for streaming and recording with medium settings for a Twitch stream. As you can see from the frame rates, the 12th Gen is running at much higher frames per second, actually over 1.8x higher, with a seamless record and stream in the background. The E-cores are primarily helping with the stream and record, while the P-cores deliver a great gaming experience running at significantly higher FPS. The 11th Gen system is actually unable to maintain the stream during gameplay at these settings, and it's dropping frames with such a demanding game. You'd have to reduce the settings or utilize hardware acceleration to deliver a great experience. 12th Gen is the world's best gaming processor, and with Performance Hybrid delivers a high-quality software CPU encode without dropping frames while delivering an immersive gameplay experience. Now let's head back to the content creation demo. A photographer recorded a video and took photos of a hummingbird over the weekend, and he wants to process them. We'll be using two different Adobe products, Premiere Pro and Lightroom Classic. You also might do something like this if you're a wedding photographer and videographer and you want to edit both types of content, or maybe someone more focused on developing stock photography and videography. We have two different systems here. We have the 12th Gen Core i9 12900K and then 11th Gen Core i9 11900K, both configured with an NVIDIA RTX 3080 GPU. We started by launching Adobe Lightroom Classic to find the photos. Once we open the library for the photos, we remember that we want to make some changes to the video we took. With Adobe Premiere, we're taking our 4K video of these hummingbirds and making some adjustments, taking full advantage of the CPU. We then export the file using a hardware transcode. While the video is exporting, we'll move over to Adobe Classic to adjust the overexposed images. When Premiere Pro moves into the background, it moves to the E-cores, while the foreground is on the P-cores to maximize performance and responsiveness. In Lightroom, we're importing 100 raw photos with a preset edit to correct for exposure and export to JPEG to share with the client. So let's see where we are across the demo. So you can see in this case that we're in the Lightroom and we're starting to do the work we just talked about to make the adjustments to the edit, and then we'll go to export them to JPEG. This takes full advantage of the P-cores to deliver a fast and responsive experience, as well as the bandwidth from DDR5. Once the JPEG files are exported, they'll check on the status to see the status on the video encode. With the capabilities of the 12th Gen platform, utilizing P-cores, E-cores, Thread Director, and DDR5, both sets of tasks can be done in parallel efficiently, minimizing system slowdown, and users can stay within their creative flow. You can see that the 12th Gen is in the process of exporting. It's actually ahead of where we are on 11th Gen. This is just going to be amazing for content creators to allow them to do their best work and to get things done quickly and efficiently. So just to go back and summarize what we're seeing across the demo. If you run these tasks serially, the 12th Gen showcases the outstanding performance of the P-cores, E-cores, and DDR5, and it's 1.29x faster compared to 11th Gen. This is just an awesome improvement, and content creators will be excited to get these benefits. However, when you layer in the multitasking capabilities of Performance Hybrid and Intel Thread Director, our content creators will get another 14% upside to improve to 1.47x faster. This is just a great showcase of everything that 12th Gen has to offer. We always hear from our customers and partners about the importance of using real applications to understand system performance. And benchmarking in this industry continues to evolve. There are several new benchmarks since the last time we spoke to you during 11th Gen launch, and a few others that we haven't talked about in the past that we wanted to highlight. First is Procyon Office Productivity. UL actually just announced this benchmark just a couple of weeks back, and it measures PC performance using Microsoft Office applications. It replaces the performance tests on PC Mark X and PC Mark X applications. Another example is Crossmark. This is an easy-to-run, native, cross-platform benchmark that measures the overall system performance for productivity and content creation, as well as responsiveness. This is available for download in the Windows Store, iTunes, and the Mac App Store. Last, for content creation. Content creation is a broad ecosystem that has many important software tools. The practitioners always want to know how a system will perform so they can get their job done. As a result, the ecosystem has developed several tool-specific benchmarks to serve that need. The Revit Forum has developed the Revit RFO benchmark to measure the performance of this building information modeling software. Catalyst Systems also has tools to measure AutoCAD performance, and Puget Systems has developed a suite of benchmarks, including covering the Adobe products. You can see the benchmark industry migrating to application-based measures of system performance. Marcus gave a preview of this earlier, but I wanted to dive a little deeper into the tremendous leap we take in performance for content creation. Across 2D, 3D, photo, and video, we see improvements from over 20% to 2x gen on gen. A few of the key technologies that are driving this amazing performance. So across Lightroom and Premiere Pro, they're very well threaded, and we see the great improvements that we get in moving to 12th Gen. We also worked very closely with Adobe to optimize 12th Gen for their new multi-frame rendering, taking full advantage of our platform capabilities and getting some just incredible scaling. The P-cores deliver responsive performance and get things done quickly, and the DDR5 bandwidth moves data at blazing fast speeds. I'm excited for our customers to take advantage of all the capabilities of 12th Gen across 2D, 3D modeling, as well as photo and video editing. While gaming and content creation always push the needs of performance and can take advantage of everything 12th Gen has to offer, we also spend a lot of time in PowerPoint, spreadsheets, words processing, and more. We've talked about how fantastic 12th Gen is for both gaming and content creation, but 12th Gen also delivers strong gains in productivity with 15 to 19% improvements. I know I spend a lot of my life in these applications, and better performance will just improve my productivity. I've covered gaming, performance hybrid, and application-based workloads and shown 12th Gen in action. We started with a leap in gaming performance, delivering up to 28% gen-on-gen performance for an immersive gaming experience. I've also shown a couple of demos that showcase how performance hybrid will allow you to game while streaming and recording with a high-quality software-based encode, and how the 12th Gen platform delivers 1.47x more performance for multitasking with photos and videos compared to 11th Gen. We'll share these workloads with you so you can try them for yourselves. Finally, we showed how incredible the performance is going to be for content creators across 2D, 3D, photos and videos, as well as office productivity. You'll soon get your hands on these amazing processors and be able to tell your readers and viewers about your experiences. We have a ton of information and details about our testing in our reviewer's guide. I'm now going to turn things over to Dan Ragland, and he's going to talk to you about some of the amazing things we have in overclocking. Over to you, Dan.
Thank you, Ivan. Hi, everyone. It is great to be here with you today. For those of you who don't know me, my name is Dan Ragland, and I have the privilege of leading our overclocking lab. I've worked at Intel for 23 years, and during this time I've had the privilege of working on more than 15 generations of overclockable products. So I'm a PC enthusiast myself. I can truly say I get paid to do my hobby, and I love it. So I say that to tell you that today, when I say that I am beyond excited about 12th Gen overclocking capabilities, you'll know that I truly mean it. Let me walk you through some content here to show you just exactly why I am that excited. So let's dive in. In fact, before we even get to overclocking, I'd like to share with you some package thermal enhancements to our processor. So in front of you here, you'll see a slide that shows you 9th Gen, 10th, 11th, on to 12th Gen. And this is a side view of the stack up of our package, starting with the substrate, then to the die, then to the thermal interface material, and on to the integrated heat spreader on top. So you'll notice there has been an evolution of enhancements over time. And here with 12th Gen, we've gone a step further. And we have thinned down the die by 25%. We've also thinned the solder thermal interface material by 15%, as well as increasing the thickness of the IHS. All that is done to improve the overall thermal capabilities of the part. So whether you're an overclocker or you're just somebody operating day-to-day and doing content creation or gaming tasks, you will benefit from this improvement. With that, let's dive into the overclocking. So again, whether you're a creator, a gamer, in the engineering scientific community, 12th Gen provides an excellent experience without ever overclocking. However, Intel has this long tradition, which I love. We listen to the enthusiast overclocking community. They love to take our processor at its best and push it further, all the way to its limits. And we're going to talk about today some of the capabilities we're providing to allow people to do just that. 12th Gen was truly designed from the ground up to comprehend the needs of overclockers. So let's take a look at some of kind of these top 12th Gen overclocking additions. So you've heard a lot about efficient cores today. We have a whole array of efficient core overclocking capabilities. We're going to talk about those in much more depth. Then we have the DDR5, which you heard about today. Well, there's a whole array of overclocking capabilities to back that up. In addition, we continue to support overclocking of DDR4. Then we've introduced XMP, Extreme Memory Profile Technology 3.0, specifically for overclocking of DDR5 memory. And then we've got a brand new feature called Dynamic Memory Boost, again, helping you squeeze more performance out of that memory. We also have created something we're calling a synthetic internal B-clock. This allows you to have B-clock on new products that may be at different price points. And we'll dig into that more. Also, we've enhanced our extreme tuning utility to version 7.5. And there's a lot to talk about there. So let's dive in. Now, before we even go into the details, I want to show you some of the SKUs available that support overclocking. So there are 6 different unlocked processors to choose from. And when paired with the Z690 chipset, you can utilize the full array of overclocking features that we're discussing today. I also wanted to point out, we're going to continue to allow memory overclocking beyond the Z-SKU PCH, just like we did on 11th Gen. But we'll be sharing more details about that in the future. So if we look at 12th Gen from a kind of a higher level overclocking architecture, we have this block diagram here to look at some of the ratio controls that are available. So we've actually designed in ratio headroom in some cases for some systems to allow you to attempt more than double the in-spec frequency. It's no guarantee you'll achieve it, but that range is there so that overclockers are not hampered by ratios. So as we look at the block diagram, you'll notice the familiar performance core ratio. That's the classic CPU ratio. That control continues, but we've added the efficient core ratio. Now these efficient cores are controllable in blocks of 4. So you have 2 blocks of 4 in the i9, and you can set the ratio accordingly for each block. So you have a diversity capability there. We continue to offer the ring ratio for overclocking. Some people call that cache ratio. It affects both. If you're equipped with processor graphics, you will have a graphics frequency ratio control. Memory ratio, as we discussed, both DDR5 and DDR4, in addition to some behind-the-scene gear choices that you can select. Then let's dig in a little bit to base clock overclocking. So you can see there we have the internal synthetic B clock option. I call it an option because we want to give overclockers choice. So for folks that just need a little bit of B clock overclocking, they're happy to control it through BIOS, we have this option. For those extreme boards that are just loaded with bells and whistles, customers can still utilize a external, or what we call discrete, base clock input. So there's choices there. And then finally, I'll just say we continue to have the capability of using a injection of a external PEG DMI clock. So if you're really pushing those discrete graphics, FPS records, you have that covered as well. So now that we've talked about kind of the high-level architecture, the ratio control, let's talk about some of the power management or some of the overclocking knobs associated with overclocking. So we offer well over 20 performance tuning knobs to help overclockers extract this performance. And our engineers have completely resynthesized this suite of tuning knobs to work on the new architecture of 12th Gen. As an example, we've added also some new features. I alluded to the memory gears. We talked about, we will talk about PLL tuning knobs. We've added a specific knob that will help you put the PLL for the cores into what we call an overclock mode, which will enable some of those new frequency records. So just to step through some of these knobs, the common knobs are things like the AVX offset. So if you're running workloads that are not AVX intensive, you can actually apply an AVX offset, which will then allow you to raise the frequency for workloads that are more SSE instruction type intensive. Likewise, we have a per core hyperthreading enable disable feature. So if you're just focused on getting your P cores to their maximum frequency and you don't need a lot of threads, you can, for that particular workload you're targeting, you could disable selectively HT threads on given cores. Again, the theme here is all about giving overclockers that total control, tunability of everything. So those are a few examples, and I'm going to jump over now to the other side here and talk about the extreme overclocking knobs. So, you know, this is used by a select few setting world records, but we care about them and we want to arm them with the latest knobs to optimize for this 12th Gen architecture. So we talked about the PLL knob recently added. We've got a B clock aware VF curve, so this will automatically tune your voltage as you raise B clock rather than that being a manual kind of guesswork game. It's automated. We have the PEG DMI overclocking I showed you in the block diagram for those world record discrete graphics items. We have the TJ Max offset, so you can adjust at what point the CPU begins to throttle due to high temperatures. And then also you have the per core enable disable, so you can literally target each physical core and say, disable core 3 if you need that for a particular scenario. So for example, if you're going after a single core world record, some folks may disable cores to get down to that configuration. So just complete flexibility. No matter what your application is, we've got you covered with knobs. With that, let's jump into our Intel Extreme Tuning Utility 7.5. I like to think of XTU really as the digital dashboard for overclocking, just like your car. You've got your steering wheel, you've got your gas pedal, you've got your speedometer, your fuel level. XTU gives you that kind of telemetry, feedback, and control right here in the software app. So you don't have to know about the architecture or those advanced knobs we talked about. It's all covered here in this simple interface. So some of the new things we've done with XTU 7.5, of course, we added all the controls for eCore, so you can control the 2 blocks of 4, which you can see here. You can adjust the temperature, you can view the temperature, and you can adjust the voltage. You have DDR5 support, so the latency values, the frequencies, all that reporting for DDR5 is available. And then we've revitalized the XTU benchmark and revved it to Rev 2.0 and integrated it with Hardware Bot. So if you're a competitive overclocker or you just want to kind of show off with your group of friends, you can overclock with XTU, run the benchmark, and automatically upload your score to Hardware Bot to share it with your friends. Now we've brought along, as I said before, the previously available overclocking features that you're familiar with, and we've actually revitalized a few of those. So one of them I wanted to talk about is Speed Optimizer. We'll show that coming up here. And the other one is a recently added feature called System Logging. And I just want to draw your attention to this because this is a very helpful tool. After you've overclocked your system and you want to see how is it doing, if I pushed it too far, is it running hot, is it running too cool and I could push it further, you can get all that kind of information from the logging function. So I encourage you to check that out. But let's say all of these knobs and nitty-gritty details is too much, and you just want the easy button. We have you covered with the one-click overclocking capability in the Intel Speed Optimizer. I love this because you don't have to know all these details. You can simply come into this Speed Optimizer, click the big blue button here you see in front of you to turn it on, and if you have an i9K, it will raise your all-core P-core frequency by 100 megahertz on all 8 P-cores, and it will also raise your E-core frequency by 300 megahertz on all 8 of your E-cores. We are also going to release an updated version of XTU 7.6 to add the same kind of functionality to the i7 and i5 K parts. So that's Intel Speed Optimizer. Now let's change gears just a little bit and talk about extreme memory profile technology. And if you don't mind, I'd kind of like to reminisce just for a second about XMP. Intel introduced XMP 1.1 14 years ago now, and really it has become ubiquitous with memory overclocking. Everywhere you go, you can find XMP memory. And XMP has one very simple goal, and I love it. Sometimes the simplest solution is the best. XMP removes all the guesswork from memory overclocking. It just works. You buy an XMP module, you plug it in, and it works. To help with this, Intel has offered a XMP tested memory list on our intel.com site. And memory on this list has all been tested according to Intel's test plan. And memory module vendors self-certify that they've passed the testing on specific motherboards with specific processors, even down to the specific BIOS version used, so that if you buy that configuration, it will just work. So today, I'm excited to share that we are announcing XMP 3.0 for DDR5. So let's jump into that. So I'm going to go over what you're going to get out of XMP 3.0, and then I want to back it up and explain how you're going to get that. So with XMP 3.0, you get more profiles, more flexibility, more capabilities, things you can control, a better user experience, strengthened dependability, and we're unleashing this new sandbox opportunity for innovation, which I'll explain and give you an example of that. Also, I'm excited to share with you that we have 6 vendors already signed on to provide XMP 3.0 memory, with others that are underway. And by October 27th, you will find on our Intel.com overclocking site a list of more than 8 modules that we've already certified as I checked this morning. So let's start to back up why XMP 3.0 gives more flexibility, more control. So first, we're going from having just 2 profiles, up to 5 profiles. So just a refresher, a profile is a configuration of frequency, latency, and voltage for a given kind of memory overclocking config. So in the past, you really could have max of 2 choices. Now we're giving you up to 5. 3 of those are vendor provided, and 2 of those are rewritable. They can come from the vendor, or the user could actually modify those 2 profiles, giving them more flexibility. Also, we're offering descriptive profile names. And it might sound simple, but imagine you have memory in your system, and in the past you had XMP profile 1 and 2. That's all you had. You didn't know what was 2 and what was 1. Is it latency optimized? Is it frequency optimized? Is it a copy of my buddy's best settings that I'm following in that rewritable section? So now you have a descriptive profile name you can put in there. So you can say gaming profile or creation profile. So you have that customization opportunity. Also, with the new architecture of DDR5, the voltage rails are derived, 3 of them are derived right on the memory module. So you have a source input voltage and then internally derived 3 rails. With that, we have the opportunity to standardize the way voltage is controlled on these modules. So we'll talk a little bit more about what we've done with that, but ultimately this allows some standardization and tools out there for programming XMP voltages. Okay, I promised you I'd give you an example of a sandbox creation here. So here's something that Corsair has developed in their IQ software. This software lets you not only view your current module settings, your latencies, your frequency, your voltages, but it also lets the user modify these settings and, moreover, store these in the rewritable XMP profile space. So this is going to create a cascading set of opportunities with these rewritable profiles, and Corsair has done a great job on this example. So if we take all the XMP 3.0 goodness and kind of try and summarize it for you in one table and maybe even add a few things we haven't had a chance to talk about yet, here we go. So we have XMP 1.0 on the left, 2.0 in the middle here, and then on the right, 3.0. And just looking at it from a glance, you can kind of get the feeling that XMP 3.0 is more than just an incremental step. It's a bigger leap forward in capabilities. And by that I mean, we've got the expansion of profiles, the descriptive profile names. I didn't talk about this yet, but there's a CRC checksum. So now that you have users doing their own rewritable profiles, you want to make sure those are written properly, and so you have a checksum there that will help with reliability. The on-DIM or on-module voltage control, that's great. And then the total number of bytes allocated, I know I'm getting a little techie here, but the SPD, we're allocating more space for XMP than ever before. You can see about 3 times the past. So as an overclocker, I got to say I'm really proud to work for Intel, because Intel decided to blaze that trail and be first to bring DDR5 to the PC. And this created opportunities, as you could imagine. As a result, we had an opportunity and a responsibility to provide a solution to the overclocking community that is XMP 3.0. Provide that solution space for DDR5. In fact, there was a whole ecosystem that had to be enabled from PMIC vendors, that's the power management ASIC vendors. That PMIC is on every DDR5 module. We had to enable an overclockable spec for that, and the vendors have participated greatly with that, along with the module vendors who are implementing the SPD side of the XMP spec. So really excited that we have the opportunity to do this. As we speak, memory vendors have these collaterals in their hands. They're building modules, they're testing them today, and as I mentioned, there's already at least 8 of them ready to go for the October 27th update. But I'm not done with talking about memory overclocking innovations. We have one more exciting advancement to share. This is called Intel Dynamic Memory Boost technology. Before you get lost in the visual here, I have a way to help you understand this simply. Think of this as memory turbo. It's automatic. So traditionally, when you would overclock your memory, You would set a frequency and operate at that overclock frequency indefinitely. It was just always overclocked. Then with 11th gen, we introduced real-time memory frequency. That allowed you to toggle between a default frequency and an XMP frequency, and you could either turn it on or off manually. So you're either always at default or always at XMP1 until you manually intervened with that click. Well, dynamic memory boost automatically and intelligently transitions between XMP frequencies and default frequencies on demand. It's fully autonomous. Its algorithms decide when is the right time to raise the frequency and when is it time to drop back. So you can think of whether there's a workload present or whether it's idle. This all happens behind the scenes. You don't have to do anything to make that happen. So we're really excited about this new feature. I hope you get a chance to check it out. And this will be made available through BIOS updates very soon. Okay, with that, I'd like to bring Jason out here to give us a demo on overclocking. Jason?
Thanks, Dan. Intel's 12th Gen desktop processors are packed with brand new features that deliver breakthrough performance. Our K and KF series processors have always given users ultimate tuning and overclocking control. We are continuing that trend by implementing new features in our Intel Extreme Tuning Utility, or XTU for short. I will also show some of the results we've been seeing with overclocking, along with updated XMP 3.0 compliant memory modules. XTU version 7.5 is available now, and we've added the compatibility to take advantage of our new 12th Gen processors. On this system I have here, it is equipped with one of the new Z690 motherboards, paired with our new 12th Gen Core i9 12900KF, which has 8 performance cores along with 8 efficient cores. The cooler we're using is a Corsair H100i, and the system has the latest DDR5 memory with support for XMP 3.0, which you'll see blazing fast memory speeds. The G-Skill modules in here can reach up to 6,000 mega transfers per second. Now let's see some of the new features of XTU in action on our 12th Gen platform. XTU has a built-in benchmarking tool. We've updated the tool to version 2.0. It is now directly integrated into hwbot.org, where you will be able to compare the results against users around the globe. Built into XTU is our Intel Speed Optimizer function. This is a one-click automatic overclocking feature for those who are looking for an easy solution to get a little bit more performance without any knowledge of overclocking. On this system, Intel Speed Optimizer was able to take our frequency from 4.9 GHz to 5 GHz on the performance cores and 3.7 to 4.0 GHz on the efficient cores, all with just a simple click. Now let's dig into some of the more advanced functions of XTU. On our processors with a K or KF designation, users can tune the frequency multipliers of each P-core individually. On supported 12th Gen processors, you can now tune the frequency multipliers of our E-cores for additional flexibility. This way, you can tune your system based on your specific needs. If you want to dedicate all your attention to the P-cores, you can. Alternatively, tuning the E-cores can turn the system into a background multitasking powerhouse. Or if balance spread is more of your flavor, the option is there. Of course, when it comes to overclocking, your individual results and experience may vary. On this system, I was able to configure a manual overclock profile, which brings the frequency up to 5.2 GHz on all 8 P-cores and E-cores to 4.1 GHz. I was also able to adjust the processor cache frequency up to 4.2 GHz from the 3.6 default. After the profile is applied, let's run a quick stress test to see the system kick into full gear. We just shown you a bunch of features that deliver a fantastic overclocking experience with every user in mind. Whether you're a beginner that can take advantage of one-click overclocking to advanced enthusiasts that can fine-tune their system with every little detail. Regardless of what tool you use to tune the system, you'll get a great experience when it comes to overclocking on our 12th Gen desktop platform. Back to you, Dan.
Thank you, Jason. That was great. Well, it's always exciting to work on new overclocking capabilities, especially when we introduce new architectures, and 12th Gen is one of my favorite platforms of all time. In fact, as I was reflecting about this, from Conroe to Sandy Bridge to Skylake, 12th Gen is going to be one of those standout platforms, one of the leaps ahead that we've taken here. Whether it's our new efficient core overclocking, the DDR5 with XMP 3.0, the dynamic memory boost feature, or our one-click overclocking with Extreme Tuning Utilities Intel Speed Optimizer feature. We've got something for everyone. If you're an extreme overclocker or if you're a day-to-day overclocker, we've got you covered. One thing I wanted to mention, I didn't discuss headroom today, how much overclocking headroom we have. And there's a reason for this. We like to leave this as a surprise and not overpromise. But I wanted to make it clear, you will not be disappointed. You will notice a leap forward in headroom. There's something for everyone to discover. Also, along these lines, keep an eye out for our Intel Innovation event on October 27th. You'll see more about this headroom I alluded to. So with that, thank you, and I'll hand it back over to Marcus. Marcus?
Thanks, Dan, and really appreciate you going through that. I hope that you all are as excited about the overclocking experience that you'll be able to run through, and that our enthusiasts will be able to get a hold of and really kind of crank up their systems. So I'm happy now to be back to show you all the SKU set that will be available at launch, because we know how all we love SKU tables. So here we go. We're launching 6 K SKUs. We've got the i9K and the i9KF with 16 cores, which are the 8 P cores and 8 E cores we've been talking about, and 24 threads featuring 30 megabytes of shared Intel Smart Cache and up to 5.2 gigahertz max turbo frequency. The i7K and i7KF are up to 12 cores, which is 8 P cores and 4 E cores, and up to 20 threads, featuring 25 megabytes of shared Intel Smart Cache and up to 5.0 gigahertz max turbo frequency. And last is the i5K and i5KF with 10 cores, which is 6 P cores and 4 E cores, and 16 threads, featuring 20 megabytes of shared Intel Smart Cache and up to 4.9 gigahertz max turbo frequency. Each of these K-SKU processors is available with enhanced Intel UHD graphics 770, which is driven by the Xe architecture, while our KF processors are available without processor graphics, but at a lower price point. There's going to be more to come on the rest of our desktop stack and our mobile family in Q1, so stay tuned. Now, while I keep this up, I actually have one last thing to show you. You'll actually be getting this pretty cool press kit as well. So inside of it, what we have, as you can see, is, if I open this up, it's pretty cool. It's got this nice quote that says, "Built for the next generation of gaming." And it's got this model. You'll want to take that out, and it'll set up this way. You'll be able to look at the kind of cool architecture where you can see kind of both the P cores and the E cores stacked on that architecture. But underneath that model is where you'll see both the i9 and the i5 processors inside. So really excited for you all to receive this, and I hope you're excited now too. So with that, we'll send it to Mandy to close.
Thanks, Marcus. So with that, we're approaching the end of our time together today. So I want to thank you again for all of you joining us today at this very exciting introduction of our most innovative and our first highest performance hybrid processor based on the new Intel 7 process. I'll just recap. With 12th Gen, we're delivering the world's best gaming processor, the best overclocking experience, and a giant leap forward in multi-thread performance for creation. Now, I want to take a second and reflect on how we got here. None of this would have been possible without our global engineering teams, which I'm particularly proud to say, include an increasing number of women. Intel is dedicated to our RISE 2030 goals to increase the number of women in technical roles by 40% by 2030. And the 12th Gen Desktop team is a great example of this, with many technical women in leadership positions from manufacturing to program management to obviously the general manager. I'm really proud of Intel's dedication to an inclusive environment, and I think it makes us able to be more innovative, agile, and competitive for our customers and to produce great products like the 12th Gen. Now, we are executing very quickly to bring the 12th Gen Intel Core desktop processors to market. And when I say that, I really mean it. I know everything has been tight in the supply chains, but we are shipping CPUs and chipsets to customers around the world today. We're putting strong support throughout the ecosystem to ensure customers can find these products in stores this year. We are expecting to ship hundreds of thousands of 12th Gen K-SKU units in Q4 and more than 2 million by the end of Q1. We also expect Q4 this year to be a record quarter for total K-SKUs shipped ever. All right, so you're going to hear a lot more about this next week at Intel Innovation. We'll look forward to seeing you there and then expect even more announcements at CES 2022.